Hey everybody, it's Bruce, and today we're going to do a video about creating an AI agent to write a newsletter. And so the newsletter is going to look like this, and it's going to go out and get news from a couple different sources like Google News and the FT, and it's going to sort these stories into clusters, like you see here, and then it's going to write to this newsletter. And this is a follow-up to a video I did a little while back about building AI agents. And this was a simple question answering agent using OpenBB. And so we can ask a question like, what is the latest price for Microsoft, Apple, and NVIDIA? And so we give this agent a bunch of functions, with that called the OpenBB framework, and get different financial market data back using APIs. And so it looks at this question and says, okay, what function do I have that might give the answer? And it says, oh, I have this function that gets a stock price. I should use that. And oh, that function takes a stock symbol. So first I have to look up the stock symbol for Microsoft and then, call the function to get the price and do that for these three stocks and gets these three answers. And then based on what comes back from the API, I'll write the answer. So that's a pretty effective agent and it's a pretty simple workflow. And so today we want to do something a little more complicated. And so we'll collect a whole bunch of data and then we will ask the AI to write this newsletter, and we'll use LangGraph, which is a module from the LangChain ecosystem that lets us do like even more complex workflows. And so let's dive in. Okay, so let's take a look at the workflow to create this newsletter. So this is a nice graph that LangGraph created. And so we're going to start, we're going to initialize, we're going to load a config file, which contains the URLs that we want to get news from. We're going to download like news, like the front pages from various, tech news publications. We're going to extract all the news URLs from those pages. Then we're going to filter those URLs. So we only want the ones that are related to AI and also that we haven't seen before. And then we're going to do some topic analysis and say, okay, what are these headlines about? So we can sort and cluster them. We're going to perform the clustering. Then we're going to download the pages that we're going to include in today's newsletter. We're going to summarize those pages. And then based on like the summaries of the individual stories, we're going to compose our newsletter. Um, and what we're going to do is we're going to go through a revision loop. So we're going to have the AI read the story, have a prompt that says, is this as good as it could be? If not, make some changes. And then when it's complete, we're going to email it to the user. Okay, so last time we wrote a simple agent to answer questions using LangChain and OpenBB, and it really just used a single prompt in a loop. And so it would go and say, what's your question? Pick a tool, or maybe it would be a couple of tools in sequence, send it to those tools, and then write an answer. And so today what we're going to focus on is like content creation. So writing like a longer, like more complex answer and using a more complex workflow like you see here with LangGraph. And so, let's talk about why LangGraph and what AI apps look like. And usually you're using the AI for one of three things. So it's going to understand human language. It's going to understand an input. Like last time, it would it would understand the question we are asking, and it's going to use the LLM to create an output. So it's going to write an answer in language we can understand, and then it's going to use tools and agentic behavior and control flow. And I'll kind of put those into one category, which is agentic behavior. And so it'll be able to pick a tool and then call the tool, which might be like a REST API, or it might write code, like SQL. So that's a fairly complex thing to do. But basically, tool use is one key component of agentic behavior, and then the second one is control flow. So it'll make decisions about what it needs to do next. And so like those are really the important components of building an AI app. So it's understanding human language and it's generating human language, and then it's using the LLM, to make decisions about control flow and to use tools. Okay, so let's dive in and just, run this complicated LangGraph workflow, like end to end. All right, so I'm going to watch this, and it's going to be running in the background. And then by the time we're finished with the video, hopefully we'll have a nice output. So the first thing we're going to do, okay, we import a bunch of stuff. I'm going to come back to this. I'm trying a couple different ways to send some prompts to ChatGPT. And then, so the way LangGraph works is you have this agent state. And then what it does in each node is going to run a function on this agent state, and then it's going to return the agent state and then send that on to the next node in the workflow. And so like the first thing we're going to do here is we're going to initialize, which is just going to load a bunch of configs from a file. And I should have that file here. So basically here I'm telling it like which of the pages I want to scrape. And I'm going to say, this is what news stories look like that I want to extract. And then some other information, like sometimes, Google News is a single page app. And so I'm going to click on the AI tab, and then maybe it's a infinite scroll single page app. So for the infinite scroll, I'm going to scroll down a couple times to try to get as much stuff. Sometimes I might say, pause if it's a site that's kind of slow, and make sure you wait for everything to load. It's complicated to scrape stuff. I don't recommend it. If you're in an enterprise framework, you should just get news feeds from, sources that have, proper REST APIs. And so I'm just doing this for experimental purposes. So, okay, so we load all these sources from our config file. And then the next step is we're going to download each one. And so here I say, like I have an option. I can either do the download or just use the ones that are in the existing directory. So like here, I'm just going to parse like the URLs using beautiful soup. I'm going to just extract them into like a data frame. And I'm going to pause now and we'll look at the data frame. Okay, so this ran for about 7 minutes. It downloaded 17 HTML files from 17 sources, and like they were in our download directory. So now it's going to extract the URLs. And so it's going to find about 1,400 links. Some of them are filtered out because they're not actual news stories. And that's going to create this data frame. So which will have the source like Ars Technica or the Washington Post, and the headline, and then the URL. Okay, so now we are going to filter these URLs to only those which are like unique. Like, so I want to filter out all the duplicates and the ones that I have not seen before, and ones which are related to AI, so that are on the topic of artificial intelligence. So the first thing we're going to do is basically check our database and filter out any URLs which we have already seen. So we just save the URLs in SQLite and then filter out the ones we've seen before. So the next thing we'll do is filter out duplicate titles and duplicate URLs. What'll sometimes happen is we might get the same headline because we got it from Ars Technica, and we also see it in Google News or in the Feedly RSS reader. And so we're just going to filter out any duplicate URLs and headlines. The next thing we're going to do is we're going to ask ChatGPT, for each headline, is this headline AI related or not? And so we don't want to send 1,000 URLs at once. So we're going to paginate our data frame and send it in chunks of 50 URLs at a time. And so we'll send it with a prompt that looks like this. You're a research assistant, you're going to categorize news based on, is it AI related or not on the topic of AI? And then I'm going to give this to you in a JSON array, like in this format, with an ID and the title. And then I'm going to give some criteria for things that look like they're AI related or not. And then I'm going to ask it to return in this format. So I'm going to get a JSON object, and then I'm going to get this array, which is going to have IDs, and true if it's about AI and false if it's not about AI. And this works pretty well. I generally get this format back correctly. And I run this in a loop, so if I do get a malformed response, I'll just retry it, but it works pretty consistently. Okay, so now we got it down to 245 headlines on the topic of AI that we have not seen before, that don't duplicate other headlines that we saw today. And the next thing we're going to do is we're going to analyze the topics of these headlines so that we can put them in the right bucket and sort the newsletter correctly. And we're going to do this like two different ways. So the first thing we're going to do is we're going to apply this prompt, which is the topic prompt. So this is the filter prompt, which asked if it was AI or not. And then the topic prompt is going to say, just look at this headline and then tell me what you think the topics of this headline are. So, I'm going to say you'll act as a research assistant to extract topics. And then here's an example of headlines I'll give you. And then here's an example of how to respond. So it'll say this headline is Microsoft, Steve Ballmer, Bill Gates, billionaires, yada, yada, yada. And so it's kind of the same before. I'll paginate my data frame. I'll send all these headlines, and then I'll get a data frame back that says, okay, here's the topics in all these headlines. So that's the first thing we'll do, which is a free-form topic extraction. And what I found was I started doing this, and then like the topics were not, they would be slightly different. Like sometimes it'll say AI, sometimes it'll say artificial intelligence. So what I kind of wanted to do is get a canonical sort of gold standard set of topics. And so as I saw kind of different topics come back every day, I just made like these, 50 to 70 like topics, like different companies and, like jobs and the labor market, and then like personalities and countries. And then so what I will actually do now is loop through the headlines. And for each headline, for each topic, I'll ask ChatGPT, is this is this headline on this topic? Yes or no? And I'm actually asking the the GPT-4o mini model like this question, and because it's so fast and cheap now, I can actually do that. And even though it's like 250 headlines times, let's say it's 80 topics, so that'll be um, so 8 would be 2000. So I think it's doing 20,000 queries. Don't check my math, but it'll actually run pretty quickly. We can see here it finished running. I had to step away for a second because it was downloading a lot of stuff and the video was glitching, but you can see here it started at it started the whole thing at 2908, and then so it ran for 10 minutes. And then you can see here it got all these headlines back. So Justine Bateman, and so it comes back with Hollywood and Society, yada yada yada. No AI allowed film festival. Okay, so we did that, and then we're going to get back a data frame, which has topics, and then like either freeform topics that it extracted, or or the canonical topics, which it got from that sort of gold standard list. Okay, so when we're doing this topic analysis, we're sending off 20,000 queries to OpenAI, which is a lot, and we kind of want to speed this up. And so what we can do is we can use the async IO module to send many at the same time. When you have an IO bound process, what you can do is you can say, okay, send this query to OpenAI, and then while we're waiting for the response to come back, like send another one, and then when the input comes back, then wake me up with a callback, and then process the input. And so we can use the operating system to basically send a bunch of queries at the same time. And like up here, like I tried to just do like a simple example, and so here like I translated these five like the sentence to like five different languages, with a template, and then I ran it sort of sequentially, like one after the other, and it took 3 seconds. And then like here, what I did is I made this little like async function, and so this basically, instead of saying like invoke like this prompt, I use the LangChain a invoke, which is asynchronous, and I say await, and then I declare this function async. And then what I can do is I can say, for D and prompt templates, make a task, And then, so I make a list of tasks and then I say, await like all these tasks, and then it'll fire them all off at the same time. And then when all the responses come back, like they'll come back here in responses. And then when I do that, like now it's 1.22 seconds. And I also tried it because I was curious. This is without using LangChain, just hitting the OpenAI REST API directly. And I kind of did the same thing. And then I used an async version of requests basically. And then I said, just hit the REST API with these 5 tasks. And, I've done this a few times. It's basically about the same. So if you want to call a bunch of REST APIs, at the same time, async IO is your friend. And if you want, you can read up on async IO and other ways of doing multiprocessing and concurrent programming, but I'm not going to go into that anymore today. Okay, so now we have good topics for all our headlines. And so what we want to do is cluster the headlines and sort them so that we can output our newsletter with the stories like sorted into topics in a coherent order. And so the way we do this is by getting embeddings from OpenAI for each headline. And so like an embedding is a vector that represents the semantic meaning of that headline. And you probably know that ChatGPT is a stochastic parrot. And so we'll ask it a question and it'll it'll output the next token, which is most probable, conditioned on the question and the answer so far, which is a simplistic way of looking at it because in order to do that, it needs a pretty deep understanding of the question and the whole answer that it's going to give. But at a low level, that's what it's doing. It's sequentially predicting tokens, and tokens are basically words, and then they're represented by embeddings, which is a long vector, which encapsulates all the meanings and connotations of that token. Okay, so just as tokens can have embeddings, we can get sentence embeddings or embeddings for our headlines. So that's what we do like here. We just call like the embedding model and get a semantic embedding for each headline. So I do 2 things. The second is the more useful one. Like the first thing, I'm sorting by topic. And then what I do is I use an agglomerative cluster sort. So an agglomerative cluster sort, just really quickly, I take my vectors in semantic space and then I can split them into 2. And I want to split them in such a fashion that each cluster is as close together as possible in semantic space, and the 2 clusters are as far apart as possible in semantic space. So I can kind of do that, and now I've kind of ordered them at least into 2 halves. And then what I can do is recursively apply the same to the 2 halves, and then eventually get a full semantic ordering. And it works pretty well. I tried other stuff. I tried regular traveling salesman solvers, but this was kind of close enough. So then the next thing we want to do is, for this newsletter, we actually don't want just a sort. We want buckets. We want clusters of headlines that talk about very similar topics. So for that, we're going to use DBSCAN. DBSCAN is a clustering algorithm, and we can say something like, whenever you have at least 3 samples like that are this far apart in semantic space, consider that a cluster. And that works fine. Like the one thing that we have to do is before we do that, we have to do dimensionality reduction because these vectors are very large. They're 3,000 vectors, and that's so like the clustering just doesn't work. When you have like a lot of columns, then the more columns you add, it's kind of like the sort of reversion to the mean, and so everything becomes kind of one big blob in this sort of high dimensional space. So you want to reduce the dimensionality, and DBSCAN is a good way to do that. And this I trained a dimensionality reduction model called UMAP, like on all my headlines. And UMAP is basically similar to principal components analysis or singular value decomposition, except while principal components are linear, UMAP can basically do a nonlinear dimensionality reduction. And again, I'm not going to, I don't have the math background to really understand UMAP. I sort of barely understand um, principal components. And but basically we do this dimensionality reduction and then we apply DBSCAN and then we get some pretty good clusters. So the next thing that we do is, so these are the clusters we come back with. And so we see like the first one is, something about like there's GM Cruise and there's like Boeing air taxis. So it's basically about autonomous vehicles. And then, what I do is like I just collect all these headlines and I send them to ChatGPT and I give a prompt that says, can you come up with a good title as the first iteration for this cluster? And that's what it comes back, autonomous vehicles and transportation. And then the next one is the new Llama 3.1 model, and then weather and climate forecasting. And so this is pretty, if we look at the headlines, like we notice here, like there's one pilotless air taxi and the rest are all about, autonomous cars. So, it's not perfect, but it's pretty darn good. Okay, so now we have good topics and we have the headlines like sorted and clustered by topic. And so now what we're going to do is we're going to limit it to the clusters, the headlines which are in well-defined clusters, which should be less than 100 headlines. And then we're going to actually download the full news article from the website. And here we're going to launch, 4 browsers using multi-threading and download these pages. And that's what was kind of like making my video glitch before because it was running all these different browsers. Okay, so now I downloaded a few dozen stories, and what I'm going to do is like summarize each story. And basically, I'm looping through the stories, and I'm applying a simple prompt. I'm saying you're a summarization assistant. You'll summarize the content, and basically, you'll give 3 bullet points in markdown format. Okay, so now I have bullet points for each of the stories that fit into some coherent clusters. So there were 2 ways I could have gone here. Like one thing I could have done is looped through the clusters, use the clusters as they come out of DBSCAN, and then write a section for each cluster. But I'm kind of relying on the magic of ChatGPT. And what I just do is I give it, the couple dozen bullet points with the headline and the topics, and then like the summarized bullet points. And I tell it to like work its magic. It says like, identify like the most important news, recurring themes, and then, some style hints. And then this is the format of the input. So it's going to be a story title, and then the site name is going to be there and the topics are going to be there. And then I'm going to ask it to output, some engaging topic title and then a couple of bullet points. And then, so I'm kind of telling it, use this as raw material and go out and write the newsletter. And I get this back. Well, actually, no, these are the bullet points I'm sending. And then this is the iteration. So you'll see autonomous vehicle developments, AI models, weather prediction, etc. Okay, so now I have a first draft of a summary, and my next prompt is an editor prompt. And I'll say you're a professional editor, you have all these skills, and then basically rewrite this so it's better. Make the titles as concise as possible, as short and engaging and as consistent with the bullet points as possible. Because sometimes it did happen that the title was a little off compared to the headlines, and then combine bullet points and remove anything that's like redundant. I don't want to have like the exact same story or very similar versions of the same story. So basically just make it better. And so I'll apply this prompt and then I will say, like the prompt will say, like respond with the updated newsletter only in markdown format or okay if no changes are needed. Um, so basically it'll edit it, and then if it comes back with okay, it'll mark, edit complete as true. And then in the state, I will count the number of iterations, this function has been run, so far. Okay, so here is like the revision that comes back, and so we can see here it says market trends, AI investments, AI intellectual property. So okay, so it shortened this title, and I'm not gonna go into too much detail, but I do find that the first version sometimes is a little off, and then it does get better. So this is a function that just determines if we're done or not. So it checks if max edits has been exceeded, which is 3, and then marks edit complete if it's true, and it'll just return complete if we're done, and otherwise incomplete. And then finally here we're going to send the mail. Okay, so what I've been doing here is just defining a bunch of functions. We haven't really gotten into the LangGraph part. The only thing that we've done is the way each function works is it takes a single argument, which is the agent state, which contains stuff like AIDF, which is a dict, which represents the data frame. But data frames are not JSON serializable like in the standard fashion. So basically, I convert it to a dict at each iteration, and then so basically, the state contains everything that the graph needs, and then each function takes the state as an input from the previous node, and then sends this, returns a state which can be sent to the next node. And I for development purposes, I set this debug flag, and then like I test this function like right after. So we've been running these functions, but not using the line graph, state machine. So this is how we set up the LangGraph state machine. So, I'm doing it within a class. So I'll create this graph, which is the state machine. And then I'll say it's a state graph based on the agent state, which is a dict, which contains like our different state variables. And then I'm going to create all these different nodes, initialize, download sources, etc., up to send mail. And then I'm going to define like these edges between the states, and they're all pretty much sequential. So I start from start, which is a constant representing the place where the graph starts, and then I initialize. From initialize, I go to download sources, extract, et cetera, until I get to revise summary. And at revise summary, I run this function in the edge, which is revision complete. And if it's incomplete, then I go back to revise summary. And if it's complete, I continue to send mail. And then from send mail, I go to the end. Okay, so I created all these nodes and edges, and then there's a step here where we compile the graph. And the compile basically adds some runtime things that we can do. And so we can add the check pointer. Like the check pointer is a database. So the database will save the state at each node as we go through it. And then it lets us potentially like restart from any point, within the graph. And then interrupt before is a compile time uh, variable that where we can say, okay, send mail is kind of a big deal. So before sending the mail, just pause, and then we can look at the state, and then if it looks good, we can say, okay, keep running, and then run the rest of the graph. Okay, self.tools, like this particular agent did not use any tools. We're not going to pass any tools. Uh, self.model, like my class, I can have kind of a default model within the class, but the individual functions we defined kind of decided which model to use. Some of them use GPT-4o, which is like the best model, and then some of them use GPT-4o-mini, which is like the fast, cheap model for, you know, asking it to pull out categories and stuff. So these are good things to have if you build an agent, but we didn't use them in this particular instance. And so, you know, here we have these functions. You know, so yeah, I defined these nodes with a class function, and the class function just calls the function we defined further up. Um, I could have put the functions like all in this one gigantic class. It would just get to be pretty large, and the way we did it makes it a little bit easier to test. Um, so, and then we have this run function, and really like the key thing here is graph.stream state config stream mode, and that says run the graph. And it, if I say for step and soft dot graph.stream, then I'll get the state back at each step. And then like config, it looks something like this. I'm going to give it a thread ID, and the thread ID, you know, potentially this could be in a larger system and lots of people could be running stuff. And so that is an identifier. So it'll store states in the database under that thread ID. And then, you know, if you want, you could kind of potentially like go back in time and restart the graph, make some changes to something, and then restart the graph from a particular node. And like debug is just how much stuff to return for each step. Okay, so I defined my agent, and then here I can create a graph. I can just get an image of what we just created, which we looked at the beginning, and that's like super cool. And then, so here I'm running it. So I'll just create a thread ID as like a random string, and then set up the config to know what the thread ID is. And then I'll initialize the agent state to having nothing in there. And then actually I'll put a couple things in there. So I'll say do download will be true. So it'll download the pages and not use whatever is already there. And then I'm going to set a date, which really should be sort of not the not 3 days ago, ideally, because I'm doing this on the 23rd. And then and then I'm just going to run it using like this initial state and this config. And then so it runs like all this stuff. So it kind of ran twice when I ran through the whole sheet. And second time it ran for 3 days, for 3 days worth of data. So when I got to this step, which is the send mail step, it stopped, because up here we said when we compiled it, we said interrupt before send mail. So basically the cell completed. And then, so I have this question, do you want to, the user input is this, is a response to this question. And then based on that, if it's yes, then it continues. And otherwise it'll say canceled. And so it's sent the mail. And then here I can inspect the last state and just see what happened. So it looks like in this final run, which was like 3 days worth of stuff, we ended up with 104 rows of worth of stories. So let's see what came in the mail. This was the one we looked at the beginning. So let's see like the latest one. This is like the final version. You know, so you know, we saw there were more stories in this section, so it edited this down, and this is all about Llama 3.1. I'm not sure if this is a healthcare story. It doesn't seem very healthcare oriented. Um, So the bottom line is it does give a nice, concise summary. Like these are like short headlines, and you know, so it's a pretty good first draft. Like in an enterprise setting, clearly you would want to have humans, participate in this process. But it did something quite useful, and I think this takes about 20 minutes to run the way I do it now, and so it's pretty darn good for what it does. Okay, so just a couple of concluding remarks. First of all, if you've watched this far, thank you. I really appreciate you. I'm not the best at these things, but I learn a lot doing them, and I hope it's useful. And then the second main thing is I think LangChain and LangGraph are pretty awesome, and they're like basically these are some pretty smart people, and they think deeply about how to build stuff with LLMs. And it's if you look at the docs, like pretty much for like any pattern that you want, there's for retrieval augmented generation, and doing a like text to SQL, and like agents, like you name it, like they have pretty good examples. And same thing for LangGraph. Like these are tremendous examples, and I definitely want to go through more of them and like learn a lot about how to do it. But there's a couple of reasons, a couple of things to think about. I mean, first of all, LangGraph is really, really young, and these things evolve pretty rapidly. So I have a feeling that there's going to be still quite a few changes to APIs, and it might be a little bit early for enterprise adoption. And then, in the case of LangChain, I kind of think anybody who's serious about building LLM apps, would benefit from looking at that LangChain. You know, that being said, like where it really excels is in building POCs. If you're doing a proof of concept, you're probably going to find a pattern in LangChain that people have done something smart with before. You're going to find a lot of options where you can like try different things, and it's just a great like learning tool. What does happen is pretty much all of the magic is in the LLM itself and in the prompts, and the applications tend to be reasonably simple. And it's taking some input from the user, it's applying some prompts, maybe in a short sequence, getting something back. So there's definitely something to be said for building production apps directly to the OpenAI API, or um, whichever LLM you're using. The abstraction at some point it kind of doesn't help as much, because once you're in production, you're not going to switch LLMs. You don't want to change a keyword and point to a different LLM. It's you might you'll if you want to change, you'll want to test very thoroughly and do evals, and you know uh, like you're not going to be making changes like as often. And there's something to be said for having stable APIs. Like everything in this business is changing very, very rapidly. And so if the OpenAI stuff is changing rapidly and the LangChain stuff is changing rapidly, it just becomes a bit much. And which LangChain is a thin extra abstraction layer. It's kind of up to you if it if for when it comes to like rolling out things in production. So like the other thing I want to say is I feel like this notion of a state machine and human in the loop and time travel. So saving the state at each node and being able to say, oh, like I should have done something a little different, and then go back and change a prompt, or change recode something, or change the input and then run it from there. Um, like that's a very powerful way to do LLM apps. And I might have said it at the beginning of this video, when, or I might have forgot. And then it's like basically LLMs can do some things really well, and then sometimes they kind of screw up. And basically, in order to get like the big productivity gain, you want the LLM to do what the LLM is good at, and you want the tools to do what the tools are good at, which is maybe hit an API, very predictably and repeatably and efficiently, and reliably get the correct data to generate an output. And you want the human in the loop, to use their critical thinking skills. And when you have a long chain of events, maybe kind of course correct, like as things, in case things go astray. And it's also, when you start doing this, like there's a tendency to make like these long, complex sort of God prompts that try to do a lot. And you definitely get a much more repeatable process if you have simple prompts that were, okay, first I'm going to categorize this stuff, and then I'm going to cluster it, and then give a really well-defined output, well-defined input to the final like summarization step. Like that's a very important, powerful thing to do, and to be able to do like these kind of loops where it sort of criticizes itself and fixes things that might have gone astray. So I think this is a very good way to think about building apps with LLMs. And also, I mean, I really feel like this might be like the way of the future for software development. And also I think this has a lot of potential for the future of software development. And I'm sure everybody's using AI for coding. It's incredibly helpful. And then people are doing stuff like Devin, which is supposed to be an AI assistant that understands the full software development lifecycle. And I'm not, like, the current AI tools are highly imperfect. So um, when I see the demos, I think there's a lot of demos out there which are extremely aspirational and cherry picked, and it's probably not going to be like a perfect assistant for some time. And so, but when I look at this, I mean, it seems a very promising direction for software development, because you can turn this into like a UI and a low code tool where I can click on this and edit the code, and when it's ready to go live, like hit a button and publish this or deploy it, like to run in the cloud, and then test it, and then edit some stuff, and then iterate it. I can kind of tell an AI, okay, this is my workflow in plain English, and it can probably generate a reasonably good cut at this, which I could then edit. And then, when I click into it, I could have, AI, could do some things pretty automatically. And, for others, I could fix the code manually, or like have a code assistant that does it. And then again, at the end of it, hit a button, say deployed in the cloud, like run it, and then have an iterative development process. A couple years ago, I looked at a lot of like low code tools, because I was working with people who really didn't want to hire like a big dev team. And so I looked at RPA and UiPath, and I looked at things like Zapier and Workato. I looked at integration platform as a service, things like Dell, Boomi, and Jitterbit. And what I kind of where I what I kind of took away ultimately was, you got to pick your poison. You can use one of these tools and they're a little bit limiting, and then you have to click on a lot of stuff, and or you can use Python, and I can do stuff pretty quickly in Python, and probably quicker than any of these low code tools. So I kind of felt like it was not really there yet. But I kind of feel now with AI, those low code tools should start to work, because if you can explain pretty clearly in English what you're looking for, it can do a pretty good first cut at a lot of stuff. And then you can kind of tell the AI to fix some things. And, we've kind of started to see a lot of like shadow IT, where people go and, build pretty complex apps just by asking ChatGPT how to do things. And so, in my opinion, this is a very promising paradigm for building, LLM apps, and maybe in the future, a lot of enterprise apps. So again, if you've come this far, like, thanks. I really appreciate you. Leave any comments below, and I'll try to answer them. And till the next time.